Well, today we're finally going to get around to actually testing some things in this Watterson radio. Yeah, I heard you muttering finally under your breath. I understand that we're moving slowly, but we're doing this for those that have not been here before. Remember that some people watching this, and if you've kept up with the comments, this is a lot of new material for someone who hasn't seen any of it before. So we need to be patient. And if you've been a little bored waiting for me to finally get around to testing something in a radio, well, today is your day, but bear with us on the patience for the young'uns. What you see is a small meter here in the foreground. Costs about $7 or $8 on the internet. I think I bought this through Amazon for $7.95 with, and you can even get it free shipping if you bundle it with some other items on Prime, for example. Over here are the knobs that I took off of this radio that you see in front of you. But what we're going to be doing is testing resistors in this radio. But before we do, I'm going to digress for just a moment. Yeah, okay, I hear you saying, not again. You keep making these videos longer and longer. To give a little help to those who are having trouble keeping up. So let's take a quick look at that first, and then we'll come back to testing these resistors. We're back at the AmericanRadioHistory.com website, and you notice here at the top, well, here's the home page over here on the left, but it says Bookshelf and International, and then you can click on the bookshelf and come down to, for example, engineering books. You can also come down here to Writer Book Library, and I'm only showing you this because you may think that just because you clicked on Writer Book Library that you're seeing all the writer books. Well, you're not. There are lots of this is the writer page, and you notice there's lots of good stuff here on everything from antennas and crystal oscillators, DC circuit analysis, gas tubes, frequency modulation. I won't read them all. Lots of stuff. And you get down to the bottom of it, and you think, well, but is that all the writer? Well, no, it really isn't. Actually, if we had clicked on the engineering and technology bookshelf, that is back here, bookshelf, come down to engineering books, we would have gotten to this page. Well, this page has some more writer books. For example, right here is a book by writer. Here is by the way, this is a very good book, this Radio for the Millions by Popular Science, 1943. If you want a very start from basic book, try looking at that one. But as you see, when we get on down here, we find things like applications of radio and television principles. And by the way, here's that over here on the left is that Allied Radio Electronics Data Handbook. Let me move down a little bit. Slide over. It's right here. And then there's this series on basic electricity. Well, the reason I brought this up is if you're having trouble with basic electricity, maybe you never studied it in high school, maybe you took it in a high school physics course 20 years ago and you've forgotten most of it, or you just like a refresher, or maybe you've never studied it at all. This is a good set of books on basic electricity. Further down, you come to books like the boy's second book. Well, here's the boy's first book of radio and electronics. Very good introductory book with some fun little radios you can build, mostly crystal radios and one-tube radios. Anyway, don't assume that any one page on this site has all the books of a particular type. Look around a little bit, you'll find a little more. And the reason that I keep coming back to books is this. I have found that trying to learn everything from video is frustrating. There are times when you just need to go back and go over something, and it's much easier to do that with a book than it is to do that with a video. You're watching a video, you get near the end and you realize, oh, there was something he said early that I missed, or maybe it was in an earlier video, and then you have to go find that and so on. It's much easier to be able to go back and forth in a book than it is on a video. So don't forget books. I know it's comfortable to sit back and watch a video and let somebody else do all the work, but there are times when if you really want to learn this stuff, you got to get the book out and read a little bit. Okay, enough lecturing. Let's get back to that Watterson radio. Now what we're going to do is use that inexpensive, okay, we'll call it Frugal, cheap, whatever you want to call it, meter, to measure some of the resistors in this radio. Now, the resistors, as you probably remember from an earlier episode, are like this. These are generally carbon composition resistors, but sometimes they also look like this resistor here or this one up here. If you'll notice this one, it looks kind of funny. It's got a purple body. It's got a brown dot. You may not be able to see that too well in the camera. And then the end is colored green and the other end is colored silver. Well, what's going on there? Let's take a look at that. Here is a page from the Allied's Electronics Data Handbook that I showed you that you can download from the AmericanRadioHistory.com website. This is the resistor color code. Now, at one time, when we talked about resistors, we talked about this kind of color code. That is a color code where you just have bands. And that kind of color code was popular after World War II. But before World War II, there was a different kind in which the resistors, some of them, the connection is around the end like this, and they tend to bulge out at the end because sometimes this is covered with an insulating material, so that because they bulge on both ends, they're sometimes called dog bone resistors, and you read those a little differently. You read the color code as body, end, dot, or bed. There also were a few where the wire just came out the end, so they look a little bit like this resistor in terms of its physical construction, but the color coding is still body, end, dot. So, for example, the resistor we just looked at in the upper right-hand corner is like this one. That is, the ends bulge out a little bit, and you read them as body is the first digit, then the end as B, so A, B, and then the dot in the center as C. Now, the colors are the same. So, for example, one of those resistors, suppose that the body, A, is red. That would mean that the first digit is a 2. Suppose the end is black. That means that the second digit is a 0. And then the dot is the multiplier. So that's C. So suppose the dot is orange. That means you multiply by 1,000. So now what we're going to do is make a few resistance measurements in the set. Now, some of you may be worried that this little meter might be inaccurate. It does have some shortcomings, but inaccuracy is not one of them. I mean, within its general range, this meter I have found is just as accurate as this much more expensive X-Tech, and quite frankly, except for the most expensive multimeters that I own, like that Keithley that I talked about when I talked about multimeters, this is perfectly adequate for measuring anything in a radio. Now, it doesn't have that 6 digits of precision that a Keithley has, or some of the more expensive flukes, but then it doesn't cost thousands of dollars either. Some multimeters can cost you as much as a real nice oscilloscope. So I don't see any reason that you shouldn't start out with a small meter like this. $8 later, you'll find that having 2 meters is a good idea. Not only can you use them in 2 places in the circuit, but also you can compare one against the other. So once you have confidence that one of them is reading the right values, you can then compare the other one. Then if you start getting some crazy values, you can then have something as a backup. But I would just start out with a simple meter like this. Don't spend a lot of money. When you realize that you're having fun with this hobby, then spend your money, get a better multimeter. But it's not because you can't do the same things with this little one. It's just that the slightly more expensive might be more convenient. For example, this one auto ranges on the ohm meter function. This one does not. So this one you have to set a resistance reading. And generally you have to set to a range that is high enough to read the resistor. If you set to too low a range, you won't get an indication on the meter. Well, it'll just say 1. So let's look at that with respect to this radio, what that means. So let's measure this resistor. It's a little bit hard to see, but the color code is green, black, orange. Well, that would be green is 5, black is 0, and orange is multiplied by 1,000. So that's 50 multiplied by 1,000, or 50,000, 50k ohms. Now, if we use this meter to measure that resistor, you may notice we just keep getting 1 ohm. My hands are in the way there, I apologize. Let me try to leave it where it is. And the reason is that the meter is set at the, let me get it up closer where you can see it. It's hard to read. 20K. Now we're going to move this meter to 200K. And we're going to measure that same resistor. Now you see it reads 49.7. Now you have to figure out that this is on the 200K range, so that means 49.7 K ohms, or 49,700 ohms. Now, if we had measured that with the X-Tech meter that has auto ranging, we don't have to set the let me back off just a little bit here. We don't have to set the resistance range because it auto ranges. Now we'll measure that same resistor using the X-Tech. $49.6K. So the 2 meters pretty much agree on the value of that resistor, but you can see the X-Tech is a little easier to use. So how did I know that resistor, what is that resistor, and how do I know what value it should be? Well, on the schematic, you notice that here is the volume control. Notice there are 2 resistors connected to the volume control. Those 2 resistors are the 2 resistors you see here. Here is one of them. This is the volume control. You remember when we talked about resistors, we talked about potentiometers and volume controls. Well, one end of this is connected to this resistor, which is a 1 meg resistor, and this one, which is a 50K resistor. Now, this is a 1 meg, and the reason I wanted to show you this is to show you something that often happens. So R8 is the 50K resistor, and R7 is the 1 meg resistor. So we look on the parts list, and we see that, sure enough, R8 is a 50,000 ohm quarter watt resistor, but R7, the other one, is a 2 meg ohm. And yet, we can clearly see in the circuit, it's a 1 meg ohm. Well, it turns out it measures about 1.3 meg ohms, but it's marked, hope you can see that, 1.3, but it's marked 1 meg ohm in the radio, but it says it's a 2 meg ohm in the parts list. Well, this is fairly common. A couple of things going on here. Sometimes there were engineering changes in a radio so that the service data has one value and the radio that you have has a different value of resistor. Same can be true of capacitors. Generally, those differences don't matter. In other words, the reason they were able to get away with a 2 meg in some of these radios and a 1 meg in others is that the difference doesn't make a big difference in performance. Another reason why you'll find the wrong value in there, that is one value in the radio and another on the schematic, is after the war especially, there was a big shortage of parts. And so manufacturers started using anything they could to get a radio out the door. So if they had a 1 meg resistor and the design called for 2 meg, they'd stick a 1 meg in. If it worked, they'd ship it. That also explains why that in this same radio you have resistors like this that are carbon composition and resistors like this, the old dog bones. These are predominantly pre-war resistors. But a lot of them were left over after the war, and there were production lines that could still be brought up quickly to build these resistors, where these newer type resistors, it took a while to get the production up. So, to get a radio out the door, if you had an old dog bone, you stuck it in. Yeah, I hear a pun coming on. Knick-knack, paddywhack, give the dog bone to ship the radio. Well, anyway, it's a bad pun. But this is what happened. Okay, I think this video has gotten long enough for now. The next section, the next installment, is going to be about how you can determine, using the parts list and the schematic, what resistance values you ought to read, because I'll give you a little bit of an idea of where we're going. What we're going to be trying to do is make resistance measurements in this radio solely from the tube sockets. So, for example, if we measure from pin 2, which is the control grid, to ground, we should read this resistor, but we may get something different. Two reasons for that. One is the resistor might have changed value. The other is there might be other things in parallel with that resistor that cause the meter to read one thing when the resistor actually is still well within tolerance. But that's coming up in the next segment. And for now, I want to wish you have a nice day.